What we have here is probably a very exciting product. It's the LV2724MR. So this unit is a 2.7 kilowatt 24 volt unit. It's not supplied obviously with this cable over here, the little plug that we've cut off, but it does come with a battery cable, 24 volt unit, and PV MC4 connectors. The only caveat you need to remember with this is that it has a limit of 600 watts of solar panel input and no more than 60 volts open circuit. So maybe two 48 volt panels in parallel, 300 watt panels will be just fine. So it also has AC outlets on the side and two USB ports and then a USB-C connector. Okay. So this little unit is 2.7 kilowatts output, so we should be able to run a microwave, fridge, TV, blender, hairdryer, all those things pretty comfortably. And here are the specifications here. So the output is 2.7 kilowatts, 120 volts, and the DC output maximum is 27 volts, and the AC output is 25 amps maximum. The rated power for solar right now, I see they've upgraded that, used to be 600 watts. It's now 750 watts. So two 400 watt panels in parallel is probably going to be excellent for this unit. And I'm going to show you how to connect the solar panels. So don't exceed 60 volts DC. Okay, so two panels in parallel, do not put them in series. So what we've done here is just hooked two panels in parallel. These are 315 watt panels each, RECs, but the 440 and 400 watt panels will be just fine. And then you've combined the two into a Y connector, so the two positives will go into one and the two negatives will go together into the other, and we're just running 12 gauge wire, a little bit long for this particular test video, but it worked just fine. So just showing you how easy it is to put up the panels. We're just using little cardboard legs to stick them up in the sun, but you're welcome to mount them more permanently. And we're going to do a little test on this this unit. It is also possible to connect 100 watt solar panels. So these are 21.6 volts. So putting two of these in series, three would be just over the 60 volt limit. It'll be about 63 volts, but we don't want to do that. So two in series, and then this will be 200 watts if they're two in series. So we could use 6 of these 100 watt panels, or even 7 of them, or 8 of them. Let's go. 2 in series with 4 parallel strings will be just fine. We're going to run our tests today with the two lithium-ion batteries. These are 12 volt, 250 amp hour batteries. So 3.2 kilowatts each. So we have 6.4 kilowatt hours of battery. We have them in 2 packages. We sell them with the silicate salts. These are 7.2 kilowatt hours, and we also have them with the battery equalizers. Battery equalizers are very important to keep both batteries running smoothly. Important note, you'll also notice that these battery cables, basically just this little plug that plugs in here, comes out. So it's very easy to make this unit portable. So it's battery powered. So just simply plugging it into a generator will not power the unit on. Okay, it has to have the battery connected. And then we're going to use our pencil method, as we've shown before, just to avoid the spark and to avoid tripping the BMS. So what we do is just take a normal pencil, sharpen it on both ends. We've shown this in all our videos. Leave the inverter in the off position. Okay, you can see that little spark over there. That simply charges the capacitors inside the inverter. And you could just do this on the positive or the negative leg right towards the end, whichever one you connect last. And that just helps protect the BMS from tripping on overcurrent on these lithium batteries, especially on all lithium batteries for that matter. So now I'm just going to go ahead and connect it, and I'm going to remove the nut and pause the video. So now the battery is connected, we can power our unit on for the first. And there you go. If you are using AGM batteries, you don't have to do anything. The silicate salts, you don't have to do any programming. If you're using lithium batteries, you could possibly get away with the AGM setting as well, just out of the box, because AGM and the lithium charging profiles are very similar, and so are the charging voltages. Otherwise, you can just set the unit to battery type user in menu number 5. Hold down the enter button, just scroll through. There's the battery type over there. Okay. So it obviously likes only changing the settings with the power switch in the off position, and then you can change that to battery type flooded or use. Use allows you to change the bulk and float parameters. The other settings will not allow you to change those settings. So let's start by hooking up a generator to this thing. Generator or utility power. It has a 25 amp charger built in. So this unit is designed for high surge loads like microwaves and hair dryers and things like that operate for a short period of time, and with only the 600 watt solar capacity or 750 watt solar charging capacity. So obviously you do not want to run behind. In other words, if you're charging with 750 watts, you cannot use 1000 watts all the time and expect the unit to charge the battery, because it's going to use 250 watts from the battery and 750 watts from the solar. Just managed to get our generator running. If we connect that up right now, I don't expect it to charge. Oh, it is. The generator is running pretty rough. And if the generator runs rough, the unit has a bad time synchronizing with the generator. Okay? See there? Still have the choke on the generator. This is an inverter type generator, so it's always putting out 60 hertz. But if it was not, see over there it's busy charging. I'm going to shut this off. If this generator was not a inverter type, you'd have to wait for the generator to kind of stabilize before the inverter is synchronized to the unit. The frequency needs to be between 57 to 63 hertz. It's important to check with your voltmeter before hooking up the solar panels. This happens pretty often as well. Customers call me saying, well, I've hooked up the solar panels, but I'm not getting anything. So right now, I'm one of those customers. I've got the meter probes into my connectors, and I'm getting no voltage. That's just millivolts over there. So I need to go and find the problem. Let's go back to the source. So I found there's 45 or 42 volts coming from my solar panels, and I'm measuring at my Y junctions 45 volts. So when I plugged in those extender cables to the inverter, that's where the power went missing. I found the culprit. That little metal tube inside there wasn't pushed forward enough, so I had to take the screw off the back, push the wire in a little bit more, and I heard a click. Alright, we figured it out. So we've got to make sure too the polarity is correct. You'll notice on that inverter it says PV plus, PV minus, and the PV plus has got a male connector going into it, and the PV negative's got a female connector. And obviously, well, I'm going to stop saying obviously, but if the polarity is switched around, then you'll have to either cut these plugs off and remake them and put the opposite way around, or cut the wire and switch the polarities around. So this is all ready to go. We've measured it and checked it, so we can just plug it in. And we'll see the solar panel light comes on straight away, which is a good sign. That little icon over there is showing us that everything is pretty good. Give it a few seconds. It's about a 15-second pole, and then it will start charging the battery. Hopefully, if this battery is not fully charged already, we'll soon see. There we go. Now it shows us charging the battery, and you can just scroll down the buttons over here to show you 41 volts coming in, and at the moment it's only 4 watts, but it's going to climb up because it's an Mppt charge controller. Wattage also depends on the state of charge of the batteries. If the batteries are fully charged, then there's no need to pull all that power from the solar panels. Just watch that climb. These batteries are probably fully charged already. So we're going to put a load on them. And there we go. So it's got a little algorithm, like an automatic electronic gearbox, that pulls power and sees where the maximum energy you can pull from those panels. We hear the fan spinning up now as well. Like this, with the solar panel on, can run a refrigerator and a TV pretty much all day, no problems at all. Especially with a 6 kilowatt hour battery. If you're putting 1,000 watts, it'll run for 6 hours, 500 watts for 12 hours, etc. And that's how the battery power works. So now we're going to start the microwave. We're going to see how much energy that's using. That's a 1,000 watt microwave. Even though the box says it's, there we go, pulling 1.2 kilowatts, even though it says it's a 700 watt microwave. I'm also plugging in a heat gun, and the heat gun is 1500 watts. I'm going to run it on stage 1. There's stage 1. That's the microwave and the heat gun going at the same time. And stage 2. So there we've got 2.5 kilowatts, and we still got some to spare for some other items, hair dryers and hair tongs, TVs, microwaves, power tools. This is the perfect unit that is portable. No power strip required. Just plug straight into the unit. This is my choice for a portable system. The only negative being the 750 watts of solar. But you can buy separate charge controllers that are cheap on the market or from us, and connect extra panels to your batteries via an extra charge controller. The unit does not need to do all the charging. You can charge externally as well. There you go. The 25 amp charging via generator. If you have a 200 amp hour battery, just remember 200 or 250 amp hour battery and it's completely empty, that's going to take about 10 hours of charging through utility power. It can charge through solar and utility at the same time, which to speed things up, just as a point for you to think about. So in this kit, it's either supplied with the 7.2 kilowatt hour silicate salt battery, which can go down to minus 40 degrees, so ideal for cabins and motorhomes and RVs that are going to go below freezing. Or it's supplied with 2 lithium iron phosphate batteries, 2 12-volt batteries in series. They do not have cold weather protection, so they need to be kept above freezing at all times. You can do that through either a heat mat or a temperature control or insulation. So depending on where you live, that is the choice. Another thing to note with all these inverters, this power switch is only for the inverter. If you turn that off, it will still charge via generator or utility power. And so you don't need the inverter running all the time for this unit to charge via solar or generator, if you want to save some power. Note, it comes with a pair of MC4 connectors in the packet. So all you have to do is crimp the wires onto the terminals, make sure the polarity is correct first, and plug and go.